Is it necessary to include hypotheses in your research paper? Stay tuned to this video as I will be talking briefly on hypothesis and to let you know if it is important for you to include hypotheses in your research paper or it is not important. Hypothesis is one of the sections that is often included in quantitative research studies, and it's one of the sections that most professors request from their candidates, their supervisees. So what is this hypothesis and why is it important, and why do your supervisor ask you to include hypothesis in your research study? So the first thing is that hypothesis is an assumed explanation of a phenomenon. That is, there is an assumed explanation of a phenomenon. What is a phenomenon? A phenomenon is a situation that is observed to exist with no clear understanding about its existence. So hypothesis is now a statement that explains that situation that is unclear. For instance, now you have a statement that says doctors more often experience work-related stress than nurses. Maybe in a topic to assess work-related stress among healthcare workers, and citing doctors and nurses as a case study. You want to know if there is a significant relationship between an healthcare profession and work-related stress. A null hypothesis is an hypothesis that states there is no significant relationship between the dependent variable and the independent variable. So the dependent variable is a variable that can be changed, while the independent variable is a variable that cannot be changed. Work-related stress can change. So it is a dependent variable. An healthcare profession like nursing or medicine, or nurses and doctors, cannot change. So you want to check the stress perception among nurses and the stress perception by doctors in order for you to know if this hypothesis is true. So now, when an hypothesis cannot be proven, if it is true or false, it means it's not a scientific hypothesis, because a scientific hypothesis must have a proven characteristics. That is, it must have a characteristic that is provable. If an hypothesis cannot be proven, it remains a proposition. Although all hypotheses starts from an educational guess or thoughts. That you just make the guess or you make the thoughts. So this guess and thought is otherwise known as proposition. So now, when this academic guess and thought can be analyzed, that is, can be measured, that is when it can be called a scientific hypothesis. But when such academic guess and thoughts or a proposition cannot be measured, it is non-scientific hypothesis. So a scientific hypothesis must have a testable characteristics. For instance, now, in the one I stated earlier, to determine if nurses have experienced work-related stress or healthcare-related stress than doctors. Now you can measure the work-related stress perception by doctors and work-related stress perception by nurses. And now subjects, and how will you measure this? You can use questionnaire to assess work-related stress by a group of medical doctors and a group of nurses. Maybe you have 10 nurses and 10 doctors. You set questionnaire on their stress perception. The answer based on how they perceive stress. You also give the questionnaire to nurses to assess their stress perception, work-related stress perception. So they also give their responses about how they perceive stress or their experience about stress in healthcare environments. Now, you can now subject the response by the nurses and the response by the doctor to a statistical analysis to determine if the stress experienced by doctors are more than the stress experienced by nurses. So, a scientific hypothesis can be a null hypothesis or an alternate hypothesis. And the hypothesis must be observable. It must be observable. And how do you get this hypothesis? This hypothesis can be from your thoughts, and you determine if it is measurable or not measurable. Can be as a result of observation in the previous studies. When you are carrying out a study or a research study, you check through the previous journals to look at the knowledge gap or what has not been done in the previous studies. So maybe in the previous studies, you have found out that these articles suggested that nurses experience more stress than doctors. Another article suggested that doctors experience more stress than nurses. So you cannot reproduce your own. You cannot collect data on your own and subject it to a statistical analysis. That's one of the characteristics of an hypothesis. It must be reproducible. You cannot reproduce your own study to know if to agree with the previous studies or the articles that you are using in your empirical review. If you agree with them, if your own findings will agree with the findings in the previous study, or if your own findings will go in contrary with the findings in the previous studies. So, other example of an hypothesis is to state that cancer patients experience more pain than sickle cell patients. So, you can measure the pain experienced by cancer patients, and you can measure the pain experienced by sickle cell patients, and now compare if cancer patients experience more pain than patients with sickle cell disease. Another example is to state that cholera are more prevalent in rural communities than in urban area. In this type of hypothesis, you can measure it. That is, you can measure the level of cholera infection in the rural communities and the cholera infection in the urban communities, and then compare the results. So when the hypothesis states that there is no significant relationship between the area and the prevalence of cholera, when the hypothesis states that there is no significant relationship, that is a null hypothesis. But when the hypothesis states that there is a significant relationship between the cholera infection and the area or the type of community, it is an alternate hypothesis because it states that there is a significant relationship. So this type of hypothesis, another person in another location can actually measure the same thing and reproduce the outcome to either be in accordance or in discordance with the previous studies or previous research. So let's check some statements that might not be well stated in a testable manner. So cannot be a scientific hypothesis, or we can call it a non-scientific hypothesis. And a non-scientific hypothesis is an hypothesis that does not have a testable characteristics, that is not testable, that is, it cannot be measured. So it cannot be known if it is true or false through a statistical analysis. For instance, a statement that says it does not matter whether or not you eat good food. There's nothing to measure. So there is no claim on the outcome of eating good food. So that cannot be a scientific hypothesis because it's not proposing an outcome which can be determined if it is true or false. Or to say cancer patients could experience more pain. Such code as a statement is an indefinite statement. So, and such statement will be difficult to measure. So that cannot be regarded as hypothesis. So hypothesis begins with an educational guess or thought or proposition, or you call it a proposition, that when it is measurable, it is called a scientific hypothesis. When it is not measurable, it is not a scientific hypothesis. And you can measure if it is true. When it is measurable, you can measure if it is true or false. And another researcher in another location can actually reproduce the results. That is, can collect data from a similar population and subject it to a statistical analysis or reproduce the results to either be in discordance with your own findings or in agreement with your own findings. And remember, it can be in a null statement. That is, when it states there is no significant relationship between the dependent variable and independent variable. An independent variable is a variable that cannot be changed. It is independent. It cannot be changed. and a dependent variable is a variable that can be changed. For instance, when you talk about eating good food daily, in the morning, in the afternoon, in the evening, good food is a dependent variable because there are different types of good food or balanced diets. It can be changed. Why daily or per day cannot be changed. So it's an independent variable. So when your hypothesis states that there is no significant relationship between the dependent variable and the independent variable like that, it is a null hypothesis. And when your hypothesis states that there is a significant relationship between the dependent variable and independent variable, it is an alternate hypothesis. So to answer your question, if it is necessary or it is a must to include an hypothesis in your research paper, I would say it is not a must to include hypothesis in your research paper. It is not a must to include hypothesis section in your research paper. But to include hypothesis section in your research paper depends on your research topic. If your topic is about, if you start your topic, you review previous studies, and there has been an educational guess in the previous articles that you have reviewed, or in the previous studies, there has been academic guess, or a statement, or an hypothesis statement that has not been proven, or there is no clear explanation about the statement, such topic needs to have an hypothesis. Or if a previous hypothesis has been tested on the topic you are choosing in your research study, most especially your quantitative research study, if there has been a tested hypothesis on the topic, it means you need to include an hypothesis in your own study as well, so that's to prove if you are agreeing with the tested hypothesis in the previous study, or you are disagreeing with the tested hypothesis. This is because that an hypothesis has been proven to be true does not mean that it will always be true. And an hypothesis that has been proven to be false, it does not mean that it will always be false. That is, when an hypothesis has proven that there is a significant relationship between, when a hypothesis has proven that cancer patients perceive more pain or experience more pain than sickle cell patients. When an hypothesis has proven that cancer patients experience more pain than a sickle cell patient, when it has been proven that there is a significant relationship between them, you can collect your own data, subject it to analysis to determine if there is a significant relationship between the disease and the pain experience. If there is a significant relationship between the disease and the pain experience. So you want to find out if cancer patients perceive more pain than a sickle cell patient. Your own findings can be that sickle cell patients experience more pain than a cancer patient. So anybody that sees that in future research can know, or can also test their own findings. And why are you testing? You are testing to provide a recommendation. One of the importance of carrying out a research is to expand the scope of practice in your field. If you're a doctor, you're conducting a research to expand the scope of practice in medicine. If you're a nurse, you're conducting a research study to expand the scope of practice in nursing. So now you want to provide a recommendation on the pain management. For instance, the type of analgesic that has been given to sickle cell patients, if your hypothesis find out that sickle cell patients experience more pain than a cancer patient, you want to recommend that sickle cell patients should be given a strong analgesic also. An analgesic that is stronger than a cancer patient, or analgesic that is stronger than patients suffering from pain that is similar to cancer. So you want to provide a recommendation that can result in good quality of life, lesser pain, good quality of life among patients with sickle cell, among patients with cancer. So it is not, if there has not been any observable event in your topic, or an academic guess, or a proposition, or a previous hypothesis on your topic, it is not a must. You set up an hypothesis, or you put an hypothesis section in your research paper. But if there has been an observation, academic guess, you can actually put an hypothesis in your research paper. I hope you have learned one or two things from this video. If you need more explanation or a consultation, kindly click in a link in the video below or around this video, and I would love to help you. Thank you.